All right, so in this section, we're going to look at rational functions and their graphs. So let's look at the definition of a rational function or rational functions. Rational functions are quotients of polynomial functions. This means that rational functions can be expressed as f of x is equal to p over x all over q over x, where p and q are polynomial functions and q of x does not equal to 0. So let me just explain this a little bit further. Well, a rational function is a function where there is a variable x in the denominator. So you may have something such as, we call this rational function r of x, which is equal to 12x over x minus 14. So because there is a variable in the denominator, it makes it a rational function. Now your numerator and denominator can be expressed as polynomial functions. So when we talk about polynomial functions, remember we talk about polynomials. It can be a monomial, a binomial, or a trinomial. So your numerator and denominator can have those types of polynomial functions in it. And then the stipulation where it says that q of x cannot equal to 0. Remember, we cannot have 0 in the denominator or we'll make this expression undefined. All right, so what we're going to look at is how to find the domain of a rational function. And remember, we have a rational function has the following form: p of x over q of x, where p and q are polynomial functions and q is not the 0 polynomial. So we just said that before. The domain consists of all real numbers except those for which the denominator q is 0. Key term here I want us to look at is all real numbers. Okay, so not complex numbers, but real numbers, positive numbers, negative numbers, 0, irrational, rational numbers. Those are all real numbers. So let's look at the first example where we want to find its domain. So let's find the domain of the following rational function. We have r of x is equal to 15x all over x minus 1. So I want to find out what number cannot be placed in this denominator, because if we place it there, it will make this denominator undefined. So to find that number, we're going to set the denominator equal to 0. Our expression that's in the denominator, which is x minus 1, set it equal to 0, solve for x, and we have here where we're going to add 1 to both sides, and we have here x is equal to 1. Therefore, 1 cannot be placed in that denominator because positive 1 cannot be placed in the denominator because it would make this rational function undefined. So here we have h of x is equal to negative 7x squared all over x minus 7 times x plus 6. So when we want to find out what numbers cannot be placed in this denominator, because if it does, if it's in that denominator, it's going to make it undefined. So what we're going to do is set the factors that's in our denominator, the x minus 7, x plus 6, we're going to set each of those factors equal to 0 using the 0 factor property. And we solve. So x minus 7 equals to 0. Therefore, we're saying when we add 7 to both sides, 7 cannot be in the denominator. So the next one, x plus 6 equals to 0, we would say, well, we would subtract 6 to both sides. X cannot equal to negative 6. So these are the following numbers that cannot be placed in the denominator. It would make this expression undefined. Let's look at another one. We have here lowercase h of x is equal to x plus 4, all over x squared minus 16. So what we're going to do, set our denominator equal to 0, and we're going to solve for x. So we're going to add 16 to both sides, and we have x squared is equal to 16. To solve for x, we're going to use the square root property. So we're going to take the square root to both sides. On the left-hand side, the exponent of 2 and the square root cancels out. We have x is equal to, and remember when we use the square root property, plus or minus, we have two solutions, so we would say plus or minus 4. Therefore, the following two numbers that cannot be in our denominator for this example, plus or minus 4. Okay, our next example, we have here h of x is equal to 17x squared plus x all over x squared plus 10. So whenever we set this denominator equal to 0, okay, we solve for x. We're going to subtract 10 to both sides. We take the square root to both sides. We know that on the left-hand side, the square root and the exponent of 2 cancels out. We have x is equal to plus or minus. We have the square root of negative 10. So in turn, it would be I square root of 10. But remember, let's go back to the domain of a function, of a rational function. It says here that the domain consists of all real numbers. And whenever we add an I to our solution, it's not a real number anymore. This is a complex number. Therefore, our domain, we would say all real numbers, negative infinity to positive infinity. There isn't a solution because this is a complex number.